Hey guys, thank you again for inviting me for this place. So my talk going to be about account abstraction on Ethereum, and it's good we do this in English. Do you know how it's in Hebrew, account abstraction? No, שיטת החשבון. That should be fun. So crypto adoption. Do we know what the adoption of crypto? About 5% of users in the world got crypto. That's kind of countries. You know, many people in Nigeria, basically in third world, the adoption of crypto is high. Do you know why? Don't have the choices. Exactly. Cool. So what's the main challenge for crypto adoption? What do you think? Like, why not everyone? Like, it's a great technology. Everybody like it. I do this for 5 years, but that's me. Why not everyone? Maybe. What? Difficulties? Difficulties? Yeah. So.
On the other hand, it's like coin.
Okay, maybe. So that's crime coin. That's my grandma not using Bitcoin because it's a crime coin. But basically, my grandpa, that's my grandma, and she just cannot use crypto because it's hard. So mass adoption crypto is terrible. We are still in 10 years in the early adopter stage, and I think because it's complex. So what's the problem? So there's two kinds of Ethereums, of accounts in crypto. There's external own accounts that everyone is aware about. That's our MetaMask account. It's basically a private key. It's controlled by a private key, and there's a smart contract account. Let's dive into the first one. So externally owned accounts, they're controlled by a cryptographic key pair, private key and public key. And account address is derived from the key. That's the account everybody's using about. And transactions are signed with the private key, and the assets are associated with the account on the account address. And the logic of this is governed by the Ethereum virtual machine. And losing your key pair, you lose access to your account. So basically, if you use a private key, you use access. So what this means? So Ethereum virtual machine. So this is governed by Ethereum virtual machine. Is governed the execution of the smart contracts. And let's see how it actually works. With the user got a private key and public key in his user space. He got in his wallet, and the Ethereum on the EVM side, there's like the address is derived by a character function from the public key. It keeps the nonce and the balance there. The EVM logic validates the transactions with the function from the private key, and the EVM logic also governs the execution. Basically, the strategy here that the users got a private and public key on his device, and the Ethereum on the EVM side is doing all the governing to make the transactions work, to execute them, and to verify them. And that makes the model of Ethereum accounts very constraining. So basically, you have one key, you can do everything with the key, and it's not granular enough for the users. For example, I want to do spending limits. I want to have a private key account that I can do some small transactions, like a wallet, like a cash. I want to spend $100 from the account, but I don't want to spend the whole account. With the private key, with this model, I just can't do this. It's very complex. So this model really puts a lot of risks on the users, because users need to be aware of the private keys. On public, they need to store them wise. They need to understand the consequences of losing the keys, and exposing the keys. So So the security model of EOS accounts is basically the authentication of the blockchain is handled by elliptic curve, signature only. It supports only ECDSA. If you want to use other types of signatures, if you want to use like BLS signatures, quantum signatures, we can't use them. That's only one thing. The replay protection, when you send a transaction, you don't want to be replayed. You don't want to send same transaction will be sent multiple times. If the replay protection is done with nonce, and the transactions needs to be ordered. So, for example, I want to develop an application, and I want to send the transactions in a batch, send them all once together. By default, I cannot use this. This logic is basically defined by the EVM. That's not the case when people write software. Like when I write software, I wanna write my backend, I write my front-end code, and I can do everything. If I want to send if I want to send some execution, some ordering all together, usually I can do this. I can write my code. That's not the case with Ethereum by default. The DOS protection, basically denial, it's done by gas fees, and then it's to pay it by the account. So the problem is basically EVM restricts the innovation of the accounts, because it's one model that should fit to all the use cases and all the developers. It's not good, not for the developers and not for the users also. One other problem is about the private keys. Basically, you need to store them, and you don't want to lose them, so you copy them, and also you're afraid of them to being exposed, so you want to conceal them. That's why basically those two push in different directions. That's why basically storing private keys is hard. So that's basically the issues. That's why not everyone using blockchain and crypto. And so why this happens? Why the private key and the public key are together? So we can think this as a concept of account. The concept of account, it got two parts. It got the signer, which authorized to spend your tokens, and it got the account, which holds the tokens. Basically, my password from a bank and my bank account. So in Ethereum, the signer is derived from the private key, and the account is derived from your public key, which also derived from a private key, and all the logic around is defined by the EVM. Let's see how it looks in banking. Banking, I sign to my bank with my password or 2FA. I got account ID, and the logic is not smart contract; it's just a code. So in Ethereum, the signer and account are basically the same, and derived from the cryptographic pair. That's basically what was caused all the problems we work around. That's what I like about crypto, that you got one private key and public key, you control everything. That's why I got into this. But that's basically what hurdles the mass adoption of crypto. So can we do better on this? Account abstraction. It's basically crypto wallets and smart contracts. And account abstraction is basically many things for many users. When people talk about account abstractions, they rely to different terms, different parts of it. For me, it's like an elephant that you can touch the elephant leg, you can touch the body, but basically you don't see the whole elephant. That's what account abstraction. So smart contract wallets, that's basically make a disconnection of accounts and the signer. Basically, you got an account which holds the token, it's smart contract, and the signer, which is owner of the account. It can be an EOA account, it can be another contract, but here you got a separation of both concept. Your account stores the funds, and you sign with the signer. So it really brings you the ownership of on steroids, because you can do any ownership models of this, any access control. You can do control lists. It can be role based. It can be attribute based. Also, it brings a user safety net to the users. You know, not your keys, not your coins. What's said in Bitcoin. So that's basically what really problematic for most of the people. So you can do recovery. You can do recovery keys using guardians. Guardians basically are kind of friends or family that can guard your accounts. And in case you lose your private key, you lose access to your account, they can restore your access. You can do spending limits. You can define how much each wallet can spend. Can define multiple users to the account, and every user can spend different amount. For example, I can do my mobile device. I can have one account that the owners are my mobile device, my laptop, and my PC at home. And then I don't know, on my laptop I can spend one amount, and mobile device I can send more funds, because I think that my mobile device is more secure. So what we are trying to abstract here, basically, what is account abstraction or all about? That's about giving contracts much more logic. So we can abstract the authentication, but using different schemas. You can use BLS, quantum resistance schemas. We can change the signer or use multiple signers, basically multisig. It's an example of it. And recovery. Ripple protection, it can be sequential, like it runs right now in blockchain, or I can do parallel. I can do batches, like Safe is doing. I can have multiple nonces if I want to. The gas, it can be configurable, so someone else can pay the gas for my transaction. That's what the ERC 4237 is doing. And basically, it comes to that, what is account abstraction? Because as I talked about, there's a couple of answers to this. It's making the smart wallets accounts first-class citizens, because contract wallets can do a lot, but the Ethereum model, as I show you, there are EOAs, they're for selling transactions, and the smart wallets are for receiving the transactions. And we want to change this. Basically, when Vitalik created Ethereum, one of the things he wanted to do first is to make the wallets first-class citizens. It didn't happen eventually. And
why didn't it happen?
So what he told about that he was really bullish on it. Basically, Vitalik is very bullish on account abstraction from day one, but they need to release it. They decided not to release it, the current version, and then to release more. They need to upgrade the EVM to allow it, because as I said, the contracts cannot send transactions, and to allow the now contracts to send transactions, they need to upgrade the EVM, and it never happened. The community was doing the search, the merge, basically focused on scaling, and the UX, it wasn't the highest priority. I believe when you want to upgrade the EVM, you can do this once in a year, in a half year. זהו? אוקיי.
אני אנסה לתקן בינתיים.
אוקיי.
תדבר חזק.
אתם שומעים? אוקיי. אז abstract account from the EVM, that's one. Basically, it's freedom for the wallets to define their own rules. As a wallet, you can do everything. You don't constrain by the EVM. I see EVM is really the first version. The first version is really the EVM. That's how the Ethereum was built. But it's for developers, and it's not good for all the use cases. With the count abstraction, when you have your security code to create the logic to verify transactions, to execute them, and basically to manage the private keys, you can do much more. And we can see this with the wallets we have now. So let's compare the both types of wallets in Ethereum. There are EOAs and smart contract accounts. So EOAs, as I said, they can initiate transactions, and smart accounts can't. EOAs don't have logic and content, and smart accounts can. Both have balance. So it's, as I said, it's clear that EOAs are for sending messages, and smart accounts are for receive them. As EOA, I sign with my private key, and I send the message to a smart contract, and that's how blockchain works. But we want to change this. So there was a couple of you have some questions? No. So there was a couple of attempts to change this, a couple of ifs. Most of them need the required EVM upgrade. The EVM need to be upgraded to do this. That's why it never happened till now. There was on Starknet, I think there's a count abstraction. They're basically more easy to do this on the L2s, but what they can devise. So what we want to do, we to make the count abstraction truly work, we need the smart contracts to able to initiate transactions. And as I said, it's so what they did in ERC 4.7, they devised an alternative flow to do this. So basically, ERC 4.7 offers an environment for sending transactions for smart contracts on top of the EVM. It's not related to the EVM. They have their own flow of sending the transactions, kind of all nodes, all operations, and it was deployed on March, and a couple of weeks ago, and yeah, there was no EVM upgrade.
It will be updated.
It's already live. No, it's already live. ERC 4.7, it's already live on Ethereum.
Yeah, but it should be merged with the EVM or
No. So what's what?
plan to merge.
No, so what's good about this ERC that it's not it did not require any changes to the EVM. It's all smart contracts and backend. So you add on top of your node, and you deploy the contracts on Ethereum. It's live on Gorilla now on the testnet. I don't think it's live on Ethereum mainnet right now. But basically, you can initiate transactions, and next I will show you really how it works. The beautiful of this approach was to enable contract accounts to send transactions and to send actions without upgrading the EVM, and doing it in the reliable, decentralized way. Because before that, you can do this with the gas station. Basically, you can do a contract and a backend that doing the same thing, but it was centralized. You need to trust some party. That's something that's ERC 4.7. It's an upgrade. It's an improvement of Ethereum. Everyone can join it. You don't need to trust the company. So the components of there's 6 components to the ERC. Is the user smart contracts, basically user operations, which transactions, basically what was transactions now the user operations. It's got a special mempool for those user ops. Basically, there's a mempool for transactions and a dedicated mempool for those. The entry point contract is a singleton contract that all logic goes through it. You can have a multiple entry point contract, but basically each entry point contract is like a different ecosystem. The paymaster is sponsoring the user transactions. It's basically the logic for customize how the gas can be sponsored. It's always actually a standard way, so everyone can build its own paymaster and use it. And the bundlers are the nodes of the system. They're basically who execute the transactions, who run the mempool, the user of mempool. That's how user operations look about. You can tell that the first lines, it really looks like a regular transactions on Ethereum. It got sender, it got nonce, it got the call data, that's a if one, it got the signature. What it adds, it's basically at the paymaster and paymaster address. It got an init code that can create the smart contract live for you if you don't have one. And some people have some verification limits that you need. So basically, UserOp is about abstracting the transaction on Ethereum. All the concept of ERC is kind of how can I take the stuff that works on Ethereum and how can I create my own flow of it that will work for the contracts. So that's the off-chain flow. Basically, I will explain how it worked off-chain, and then we come to the smart contracts. So the wallet sends the operation to sending the user output to the mempool. It needs to be simulated and needs to be checked. Basically, the wallet can pay for the gas.
The wallet is the smart contract or the EOA?
No, sorry, the wallet is the application. Okay. Yeah, it's option flow, so it's basically your mobile wallet or MetaMask. Okay. Yeah. Basically, you use the send user operation is the command, is the JSON-RPC command that is added to the standard. Like not all nodes need to support this if, because this if is it's not an upgrade. You can, but I believe that most of the nodes will support it. I already see like companies like Alchemy going to support account abstraction on their platform, in Infura maybe. So many nodes, the RPC will support this, and they will have dedicated RPC methods to use the ERC. So the operation goes to user mempool. When it needs to be simulated, it needs to be basically checked that someone can pay the gas before the execution. Then the bundler, which is the node of the system, basically all user of mempool, the bundler and the TX mempool, they basically can run on one node. Think of your gas node or Ethereum, your gas node that runs the bundler on the site, and they communicate on one machine. Of course, the TX mempool and the user op mempool, they need to be decentralized and shared between nodes, but basically all this can happen on one machine. Yeah, off-chain towards, I mean, like, backend to backend, like client, that's the client, wallet is the client. Yeah, so just the wallet is the client. Here, all this is a JSON-RPC. I send it to my backend. And all these flows think of it happens on the node, the blockchain node, or gas, or Nethermind. Nethermind actually supports this flow, will support. So basically, the bundler takes user ops from the mempool, and he executes and he validates them once again, and then he builds the transactions and execute it. So this basically transaction, the regular transaction happens here. So the simulation is interesting thing. Basically, there's some time between like this simulation here in the user mempool and when the bundler sends this on the blockchain. So the simulation needs to check that the wallet or someone can pay for the gas. So So that's why it cannot use some methods. For example, you can use the block number and other things. So that's why between the simulation and the execution, we need to make sure that everything works in the same way. Yes.
The paymaster has like a maximum amount of like a maximum way amount that can pay for transactions, because sometimes the network can be congested and you can restrict it.
So if paymaster cannot pay for the transaction, it will be shown the simulate stage. Simulate stage will fail, and again to that it will give the answer that it can pay for the transaction basically.
What if it happens between blocks?
What do you mean? Yeah, simulate and execute.
How is the bundler is guaranteed to receive the gas?
So that happens in the contracts. I can show you the on-chain flow, and maybe it will expand this. So that's the on-chain flow. Basically, the bundler sends the handle ops method to the entry point contract, and if there's a paymaster, the entry point will validate for each paymaster if it can pay for the transaction or not. Then it will validate the transaction again with the smart wallet and execute it. And the smart wallet can basically, the smart wallet sends the message to the target contract. Does it answer to your question?
I'm not sure I understand if the bundler is guaranteed to receive the funds.
Okay.
The transaction cannot be crossway all the way to receive finality on the blockchain itself, and he's not getting the gas.
Okay, so he gets the gas fees in the same transaction. That's one transaction for the paymaster got a method.
So if something breaks in the middle, everything reverts.
Yeah, but basically everything reverts. That's how it works. The problem with it is that if this reverts, you still pay gas for a failed transaction. That's why there's a simulate phase. That's why there's two simulations here. That's why you simulate here on the start, and also bundler also runs another simulation.
What's the incentive for the bundlers to do this? They receive gas, they have to pay the same gas.
That's a good. So the bundler just gets. That's a good question. The bundlers just get the fees back. They can use the paymasters, and the paymaster can basically the bundler can use their own. So the model here, the bundlers not should receive everything, but the paymaster can decide on the logic. As I see it, the paymaster and bundler need to work together. Basically, I have a bundler and I have a paymaster that basically, and then I can charge some money from the user with this. And I thought, look, that's my paymaster, that's my bundler. You can use me. Any other questions? So let's basically let's slide of this. Any more questions?
Thank you.
Okay.